Good morning, everyone. We are back with another edition of SAT Khan Academy Problems being solved live on camera. And today we are tackling circle theorem problems. So without further ado, let's jump right into the mix on this Monday. So we're going to go to the screen share. And now let's jump into it. Here we go. Copy. Oops, this is from last time. And let us begin. Oops. Hope you guys had a great Mother's Day, of course. Okay. Here we go. The semicircle shown above has a center at point O. The sector of the circle formed by angle NOM. So this guy. Let's just make sure we know what we're talking about. This is what they're talking about. NOM. Ooh, not bad though. Has an area of 6.25. So this sector, 6.25. The radius of the semicircle is 2.5 that we can see. What is the radian measure of angle LON shown in the figure? So this is a little bit of a tricky question here. And this is how you're going to approach it. You pretend that this entire circle would go all the way around, okay? If that were the case, then now by the way, they're talking about radians. So then in that case, the area, remember, area is just pi r squared of a circle. And it's giving you the area of this sector. So first, what would the theoretical area of this entire circle be? We'll plug it into this formula. Pi times 2.5 squared. And I believe that is 6.25. It is a non-calculator, so I can't even use, wait. The sector of the circle form. Yeah, that's crazy. So it's 6.25. I mean, you could write this out if you didn't have to. You didn't want to do it mentally, you could have done this. I just know 25 times 25 is 625. So 6.25 pi is the area of the whole circle. We're trying to find this measure, right? We're trying to find angle we're trying to find LON. Okay. So this is a few different steps involved here. So then basically what's happening is when we calculate this area, 6.25, it's like we're taking the whole area. So first I'm going to calculate this angle NOM. So first I'm going to take the area of the entire circle, and then we multiply it by the ratio of NOM, which we'll just call it X, over 2 pi. Because if we do this, now this is exactly how we find 6.25, which is the area of our sector. You take the ratio of this angle here over 2 pi, which is 360, which goes all the way around. 2 pi is equivalent to 360 in radians. And that would equal our sector area. So now let's isolate this a little bit more. This, if we multiply this across, it becomes 6.25 pi x over 2 pi equals 6.25. And then this crosses off. And then we have 6.25x, we can multiply 2 across here. We have 6.25x equals 12.5, right? And then if we divide both sides by 6.25, we just get x equals 2. So what does that mean? That means, and what were we solving for? We were solving for this angle right here. So strangely, but this is again in radians, NOM equals 2. Okay, now we're almost there. Now A, okay, you notice that this is a straight line. So that means these two angles, A and NOM, are supplementary. So that means to get A, all we have to do is subtract this NOM angle from 180. But we're not in degrees, we're in radians. The equivalent of 180 degrees is pi. So we'd say pi minus 2 would give us this angle. And I saw this answer in here before. It's C. That's all you have to do. You don't have to calculate You don't have to simplify or calculate it down to an approximation. So I believe pi minus is a pretty hard problem, actually. And yes, it is correct. Okay. And it looks like they did it pretty similarly to the way that we did it. So that is not an easy question. Let's go on to number, what is this one? 2. It's been a pretty long weekend work-wise and all else-wise. Feeling it today. Question 2. The circle shown at left has its center at point O. Line segment MN is a diameter. The measure of acute angle LOM. LOM is 0.6 radians. The shaded sector of the circle formed by the obtuse angle LON as area 6. What is the radius R of the circle? Okay. All right. So we need to find this area. The way we do it is, no, sorry, we don't need to find the area. We know the area. It's 6. We need to find the radius. So this is how we do it. We use our sector area formula to calculate this. So normally what we do, we're trying to find LON, which we'll just call X. Set up the same type of thing, X over 2 pi. That is our magic formula. We take the angle over the 360 degrees, and we multiply this by the area of the circle. I'll just put that in as the area for now. Area of circle equals 6. Okay, because 6 is the final sector area that we're trying to find. And now we can wait. Oh yeah, we're trying to find radius. So there we go. So now let's try and figure out what is this X. You know what? No, sorry. We're actually not trying to solve for LON. We're trying to solve for radius. And X we know. We actually know what this angle is, because we know that this line is 180 degrees. We know that this angle in here is 0.6. So to get X, it's literally just 180 minus 0.6, or in radians, pi minus 0.6 over 2 pi. And then what's the area of this circle? Well, it's pi r squared, but r is what we're trying to solve for. We'll leave it as r equals 6. Man, now all we got to do is solve for this equation. It's pretty hectic. It's pretty crazy. Let's go ahead and do that. Let's multiply both sides by 2 pi. Okay, to get rid of that denominator on the left side. Okay, so now let me go up here. Can I have a lot of work here? Pi minus 0.6 over, oh no, we've gotten rid of the 2 pi. Pi minus 0.6 times pi r squared equals 12 pi. Beautiful. Let's distribute this. And then we've got, actually no, let's divide both sides by pi minus 0.6. Pi minus 0.6, pi minus 0.6. That goes away. Now we've got pi r squared equals 12 pi over pi minus 0.6. Now that we have that, we can divide again by pi. Okay. Now what happens here, sometimes I do it like this to figure out how this goes. I kind of make it a fraction over fraction. I just remember the insides go to each other, the outsides go to each other like that. So now we have r squared equals 12 pi over pi times pi minus 0.6. Oh, and actually these two cancel out. I didn't even see that before. Should have canceled them out before. So now we got r squared equals 12 over pi minus 0.6. These are not easy problems. And then I got a square root both sides, so we're trying to find r. So there's our answer. It's the square root of 12 over pi minus 0.6. And that would be D. Although it's not simplified. We could simplify the top, but they didn't even do that here. Should be 2 root 3, but that's okay. This looks good. Oh, we found our answer. Let's see if we are correct with D. These are no joke. Yeah, that's right. I would definitely watch this video again if you find these to be tricky, because they're pretty involved, or fairly involved, I guess. Let's go to number 3. Here we go. The sector of a circle shown at left has center Z. The length of the chord XY is 24. Wait, sector. Center Z. Where's center Z? There it is. The length of the chord is XY. This guy's 24, and we got that nicely in here. The distance from Z to the chord is 5. Okay. Finally, WZ is perpendicular, right? It makes that right angle perpendicular, and it bisects XY. Okay. So that means the only thing I could add is this guy's 12 here. And this guy's 12. Bisect means it cuts it exactly in half. What is the radius of the circle? Ooh, all right, interesting. Oh, I can already, well, actually, all you need is Pythagorean's theorem. And I don't know if they intended for, no, they must have intended for that. It's 13. And I'll show you why. When you add this 12 and you realize you got 2 right triangles here, you got a 5, 12 something, 5, 12 something. This is the radius is also the hypotenuse. So we can do a little Pythagorean's theorem. 5 squared, which is a squared, plus b squared, which would be 12, equals our radius squared. This is 25 plus 144 equals r squared. This is 169 equals r squared. To get r, we take the square root of both sides. And 169 is a perfect square. It's actually 13. So unless I've completely overlooked something, it should be 13. This was far easier than the other two. It is. Yeah, they did Pythagoreans as well. So that they literally threw in one that was not so bad. Not so bad. All right, let's try number 4 here. Number 4. Here we go. A metal wedge to be used as a corner brace is the shape of a quarter circle shown at left. Angle ACB is right. The length of the chord AB is 2. What is the length of the arc ADB? Got it. So we know that's 2. Okay, here's what's the dealio. This is a quarter. This is the quarter circle. This triangle, we know because it's 90. These are both radii, so these are equal. And that means it's an isosceles right, which means these are 45. These are 45, has to be. It's the only way that all 3 angles will add up to 180. So isosceles right triangle. Now, isosceles right triangles, you could actually use Pythagorean's theorem to solve for the radius. We need to solve for the radius, and I'll get to that why in a second. Or you can just use your knowledge of special right triangles. And all you do is this side and this side to get to the hypotenuse. You just multiply them by the square root of 2. So to go back to the smaller legs, we divide by the square root of 2. Another way to think about it is if we call this x, these are both the same, right? So it's x squared, this is Pythagoreans, plus x squared equals 2 squared. So this is 2x squared equals 4. Divide both sides by 2. We get x squared equals 2. And then square root both sides, x equals square root of 2. And that's what these guys are. Or, you could also, like I said, divide 2 by the square root of 2. It's the same thing. Once you kind of simplify, this becomes 2 root 2 over 2. And we got root 2. So square root 2, square root 2. Now we have to find arc length. So what's the formula for arc length? It's just like this. It's literally just 2 pi r, which is the circumference of the whole thing. And then in this case, this is a quarter circle. It's literally 1/4 of that, right? A quarter circle, 1/4 of the whole. So 2 pi r over 4 in this case. And usually we take that interior angle, which is 90 over 360 or whatever, but we know 90 over 360 is 1/4. This is 1/4 of a circle. Now we just plug in our radius, 2 pi square root 2 over 4. Cross this off a little bit. These guys reduce. 2 pi square root 2 over 2. This becomes a 2, right? And that should be your answer. Pi, and it's this. They wrote it a little differently, but it's pi, square root 2 pi over 2 centimeters. And that should be our answer. And it is correct. Excellent. Let's end it with number 5. Number 5. Move this. Here we are. The circle shown at left is center at point O. Chord AC is perpendicular to radius. Chord AB is perpendicular. Excuse me. AC is perpendicular to radius OD. Cool. And intersects OD at point B, right? That's cool. I'm going to change it to red. Line segment OB has length 8. Yep. And line segment BD has length 9. Yep. What is the length of chord AC? We're trying to find AC. Let me think about this for a second. We got some right triangles. We got our radius is 17. And do we know? Oh, wait, and it wants to find AC. Oh, I see. Okay. We know that this whole thing, OD, it doesn't tell us this, but OD is 17. Okay, right? A plus 9 and 17. But we also know that OA, therefore, is also a radius because it goes from the center out. So this is also length of 17. This is also length of 17. So I've seen these problems before in the SAT. It's just figuring out that those are also radii. And then, I mean, once you do that, this is nothing more than Pythagorean's theorem all over again. So we got 8. We got a hypotenuse of 17, and we're trying to solve for the long leg. We're trying to solve for this guy, for AB. And then we have to double it, of course. So let's go ahead and do that. We got 8 squared plus x squared, that's our AB, which we got to solve for, equals 17 squared. This is a non-calculator, by the way. I think I remember 17 squared. I think it's 289. It's equals 289. I'm pretty sure that's right. And we'll double check in a second. We're going to subtract 64. Subtract 64. And we got x squared equals 5, 2, 2. It's definitely right then because we get a perfect square. I'm sure it is. And then we square root both sides. Square root both sides. X equals square root of 225 is 15. And they're nice. They didn't actually put 15 down because a lot of people could make that mistake. Remember, 15 is just the length of AB. This guy is 15. But we want AC. It's double that. Therefore, it's 30. I'm going to double check that 17 squared is indeed 289. I'm kind of remembering it off the top of my head. Because that's the last square root I think that I've memorized. Or last perfect square. 9. So I could be wrong. 4, 7, 11, 0, 7, 1. Yeah, that's right. It is indeed 289. That's it. It is B30. I think. Let's make sure. Yes, we are correct. All right. Let's jump back in here. All right. So that's it, guys. I hope you enjoyed. I hope that was fun. And if you have any questions, please make sure to leave a comment in the comment field below and like the video if you found it helpful. And lastly, please subscribe if you haven't done so yet to make sure that you get all the up-to-date information on math, SAT, education, all that good stuff. We're almost done with the SAT Khan Academy problems. We've almost gone through every single problem type, which is really cool. It's taken me a while to do that, so pretty happy about that. That's all. I hope you guys have a great Monday and a great week. Take it easy. And boom.